Okay, let's unpack this. We're looking at something pretty unexpected today.
Definitely. Calculus showing up in animal husbandry, specifically cow barns.
Right. You sent over these sources talking about managing the environment inside livestock barns, keeping animals comfortable, healthy,
Sounds straightforward enough on the surface.
but then you factor in, weather, the animals themselves, even what's happening in nearby crop fields.
And suddenly it's this really complex, dynamic system. It's constantly changing.
Exactly. And navigating that complexity, according to these sources, relies on calculus.
Yeah, specifically differentiation and integration. Which seems kind of wild, right? These math concepts.
The ones you wrestle with in class?
Uh-huh.
Right.
Becoming, well, essential tools for something very hands-on, like animal husbandry technology.
It's fascinating. Our sources really focus on how differentiation and integration are used to analyze temperature shifts inside these barns.
And especially those barns located right next to active agricultural crop zones. That adds another layer of complexity.
It really does. So I guess the big question is, how can this math, rates of change, accumulation, how does that help manage barn climate?
Well, that's exactly what we want to explore in this deep dive. How does calculus give us the precision needed for these real-world challenges, make it make sense?
Okay, so let's picture that barn temperature. It's not just one number.
Yeah.
It's always moving.
Always. It's a function of time, goes up, goes down, depends on ventilation, animal body heat, outside weather.
Like a sudden rain shower or afternoon sun hitting the roof.
Or even, like the sources mentioned, dust kicked up from harvesting next door. All these things influence it.
So this is where differentiation comes in.
Precisely. Differentiation lets you calculate the instantaneous rate of change.
Meaning not just if the temp went up, but how fast it was climbing or falling.
Exactly that. At any specific moment, if you graph the temperature over time, differentiation gives you the slope of that line right then and there.
Got it. And the sources stressed why knowing that specific rate is so important. It's not just knowing the temperature hit a danger zone, but maybe how quickly it got there.
Right. A slow, gradual rise gives you time to react, but a really steep climb.
A high positive derivative, mathematically speaking.
Yes. That could signal something urgent, like a ventilation system failure or a sudden change outside needing immediate attention.
So it helps pinpoint those critical moments of rapid change.
Exactly. It gives you real-time insight into the system's dynamics. Okay, so differentiation is about the rate at a moment.
Right.
Integration, on the other hand, lets you look at the cumulative effect over a period of time.
Ah, okay. The total impact. So if differentiation shows the speed of the change, integration adds it all up, like the total heat stress the animals felt during a hot afternoon.
You got it. By integrating the temperature function, or maybe a derived function like a heat stress index over, say, several hours, you quantify the total thermal load.
Okay.
It's the math behind calculating things like degree hours above a certain comfort level.
And the research suggests that's actually more useful.
Yeah, according to what we read, that kind of integrated data, that total exposure, is often a better predictor of long-term animal health and productivity than just looking at, like, the single highest temperature reached.
That's really interesting. So differentiation spots the fast problems. Integration measures the total toll.
You could put it that way.
But how does the location near agricultural crop zones specifically play into using calculus here?
That's a great point. The sources highlight that these barns face unique external variables.
Like what?
Well, think about dust from plowing or harvesting. It can clog ventilation filters, right? Which impacts airflow and therefore temperature.
Oh, great.
Or nearby irrigation. It might increase local humidity, maybe cool the air slightly.
But how much it cools, or how fast, could vary wildly depending on wind and time of day.
Exactly. So differentiation could help you measure, say, the rate at which that dust buildup is impacting ventilation efficiency.
Or the rate of temperature drop when the wind shifts after irrigation starts next door.
Precisely. And integration. That could quantify the total amount of dust collected on a filter over a week.
Okay.
Or the total cooling effect from that irrigation over the course of an afternoon. The interaction between the barn's internal systems and these outside factors from the crop zones, it's complex.
So simple temperature readings aren't enough.
Right. Calculus gives you that robust framework to model these multiple dynamic inputs together and really understand their combined effect with precision.
It really seems like calculus transforms it. You go from just reacting to temperature changes to actually understanding why they're happening, how much they're changing.
And the longer-term consequences.
Especially with those tricky outside influences from the fields. The sources make a strong case for how these math tools turn simple observations into, like, powerful, actionable insights.
Definitely. Insights for managing animal welfare, barn efficiency. It's
Yeah.
quite practical.
What stands out is seeing these concepts, which can feel so abstract, providing real, quantifiable answers to these, well, very practical problems in agriculture.
It helps move beyond just noticing things fluctuate to actually understanding the mechanics behind it and the total impact.
So, wrapping this up, the core idea is that calculus differentiation for rates, integration for totals, gives us the necessary tools
A mathematical lens.
to analyze dynamic systems like barn temperature, especially when influenced by external factors like nearby farming.
Mm.
It's theory solving real-world problems.
It enables much more sophisticated modeling and prediction than just basic measurement allows.
So, thinking ahead then, if differentiation helps us understand the rate of barn temperature change, particularly with those crop zone factors,
Yeah.
what other tricky environmental factors in agriculture, maybe things like soil moisture changes or even the spread of airborne pathogens, might we understand or predict better using calculus?
That's a really interesting question to ponder.
Something for you to think about until our next deep dive.